class. Yesterday we learned about derivatives, and we're going to continue on with that today. So I'm just going to remind you of the few basic rules that we learned yesterday. So the first one is if we have a function that's a constant, the derivative of that constant equals 0. Number 2, if our function equals a constant times x, the derivative of that equals c. And last but not least, if we have a function that is x to a constant, then the derivative of that equals the constant times x times to the constant minus 1. Okay? So now we are going to apply this into a real life situation. I'm going to write the problem on the board. A car rolls down an incline. Traveling S of t equals 3t squared plus 7 feet in t seconds. Find the car's velocity at time t equals 3. So, this function here is called the position function. And that's basically just our original function. So in order to find velocity, we need to find the first derivative. Of s of t. So s of t equals 3t squared plus 7. What is the derivative of s of t?
6t.
Yep. The derivative is 6t. Now, we are going to set this equal to 0 because that's how we find the velocity. So that is t equals 0. Now I'm going to draw a number line right here, and I'm going to put 0 there because that's our critical point. And I'm going to test a number in each section by plugging it into the derivative. So if I plug in -1, because that's in this section, we have 6 times -1, which equals -6. That's a negative number, so I'm going to put a little minus sign to show that it is decreasing. Now let's plug in 1. Well, 6 times 1 equals +6, so I'm going to put a plus sign, and that is increasing. So if it's a negative number, when you plug it into the derivative, it's decreasing, and if you have a positive number, it's increasing. So what this is saying is our function, as it's decreasing until 0, and then starts to increase again like that. So now what we're going to do is plug in 3 for t, because t is our time, and we want to look at this function when we're at 3 seconds. So s prime of 3 equals 6 times 3 and that's equal to 18. That's 18 feet per second. So, after how many seconds will the velocity be 66 feet per second? Well, what we would do is say that 6t, because we don't know how many seconds, equals 66. And what is that? T equals?
11.
Yep, it equals 11. Good job. Okay, so if we wanted to find the acceleration, we would just need to find the second derivative.
Oh, hey, we learned this in our physics class the other day.
We should do an experiment. We can drop an egg off a bridge.
That sounds like a great idea. Next Friday during class, we'll go outside and we will experiment with this. But first, I need to teach you about integrals.
Alright, teacher, can we show you how we do it in the physics way?
Of course.
So in physics, we start off with the acceleration function, and for all free-falling objects like the egg, the acceleration function is a of t equals negative 9.81 meters per second squared.
Now we're looking for the distance function, which require two integrals of the acceleration function. But the first one, which is the velocity function, velocity of t is equal to the integral of a of t, which is equal to negative 9.81 t plus v initial.
Now, in order to get the position function, we need to take the integral of the velocity function. That's the integral of v of t which would equal 1/2 negative 9.81 t squared plus the initial times t plus the initial distance.
Now, from our video recording of the egg drop, we had an average time of t is equal to 0.77 seconds.
And our initial velocity we know is 0 meters per second because the egg was just dropped, and if it was just dropped, there was no initial velocity added to it. So v initial equals 0 meters per second.
So, now by plugging in the time and the initial velocity, as well as having a final distance of 0, because that's where the egg hits the ground, so d of 0.77 is equal to 0 meters.
So we just plug in all our values into this equation. So it'd be 0 equals 1/2 negative 9.81. Our t is 0.77 squared plus 0 times 0.77. And then our initial distance is what we're trying to find.
Now after you do some algebra, you end up with d0 is equal to 2.9 meters.
Or 10 feet, just about. This was the initial position from where the egg was dropped. So So then our overall position function would be d of t equals 1/2 negative 9.8 t squared plus our initial position, which was 2.9.
So Maria and Justin, what did you just prove?
Well, after all of this work, this just goes to prove is what you did earlier in the week, or the week before, however long it's been since we've last seen it, that either doing it in a physics way or a math way, you can get the same answers.
And both math and physics use integrals and derivatives to solve different problems.
I'm ready to... Just hit the video recording. I'm ready when you are.
I'm good.